Hello everyone, in this video we will be moving on to the module 2, site selection and planning. So site selection and planning has several aspects within it, and it goes like selecting a suitable location, site ecology and site ecology based surveying, and various subsets of site planning aspects. So in general, site selection has to be made preferably by cautiously make decisions, like we have certain preferences and avoiding criteria. So under preferences we can see that one should prefer greyfield and brownfield or urban landfill sites over green fields. So you should understand what is mean by these different field based terms. Greenfield indicates a fresh land where earlier there was no development or that there was no industrial activity was happening, preferably empty plot or might be an agricultural based plot. Greyfield on the other hand indicates the pre-existing plots where already some building developments was happening and it might not be completely utilized currently. Brownfield indicates land contaminated sites where some left out industrial activities were happening, right? So those kind of different types of fields are there. So under the site selection based preferences, one should prioritize greyfield or brownfield or urban landfill sites over green fields. And apart from that, this will conserve green fields and farmland regions. So that would be the major reasons why these kind of preferences should be made. So on the other hand, according to the avoidance criteria, so the locations with ecological features in the close vicinity such as water bodies and wetlands has to be completely avoided, because that would help in preventing imbalanced urban growth. But on the practical aspect, if you take any typical Indian cities like Chennai, Bangalore, Pune, so everybody is struggling with because of that particular avoidance criteria negligence only. So every here and there new building developments or infrastructure developments are being planned and made on existing water bodies or the place where the water might be flown and being as a catchment area. So that has to be understood very seriously, and those kind of sites has to be avoided. So on the other hand, so under preferences criteria, we have site with close proximity to some basic amenities should be preferred. So what are those basic amenities? In the sense, it consists of any one or couple of or combinations of these listed 11 items. So it might be ATM and bank, clinic and hospital, schools and colleges, grocery stores, and departmental stores, then laundry, dry cleaners, parks and gardens, pharmacies, government service utilities like post office, any other government services outlets, courier service, restaurants, cafes, sports, fitness center, and theaters and malls, right? So these kind of the places are more often visited by the localites. So ideally it should be preferred, the site should be preferred so that couple of these amenities are closely located. So that choice of choosing a site having a close amenities of all these things would minimize travel time and distance. So that would allow choosing the alternate transportation and eventually reduces the vehicle emitted pollution. So as per the IGBC recommendation, the ideal choice, so you should choose a location or site within 800 meter of walking distance from nearby railway, metro or bus station, right? So site ecology and site ecological based survey. So what are they? Why it is needed? Site ecology, if you see, it evaluates the natural ecosystem that includes plants, animals, soil and water on a potential building site. So it ultimately focuses on minimizing disruption and enhancing ecological balance during site selection and development. So site ecological survey means it's a detailed assessment of the existing flora, fauna, soil and water conditions, water bodies and their age and their spreading in terms of area and the quantum of water it holds within it on a potential building site before development. Because once you take up such a site ecological survey, then your design should align with those ecological features in your chosen site. So how it benefits ultimately? So it identifies sensitive habitats, species and ecosystems, allowing for strategies to protect and preserve biodiversity during construction and development, right? So it also helps make well-informed decisions by understanding the ecological features of the site, ensuring minimal disruption to the natural ecosystems. It also ensures compliance with local and national environmental regulations, reducing the risk of legal issues and delays in the project. It ultimately guides site planning to integrate green spaces. That green spaces are nothing but existing site ecological features. Green spaces and enhance ecosystem services, promoting a more sustainable and resilient development, right? So it ultimately encourages the preservation and enhancement of natural habitats, leading to improved site ecology, reduced carbon footprint and a healthier environment over the building's life cycle. So under the site selection and planning aspect, so we should mandatorily take up a site ecological survey so that to develop a well attributed ecologically designed construction project. So if you jump into the other aspects, detailed aspects under site planning and selection, we are having site analysis as the first thing, right? So in all these aspects, who are the role players? If you see, owner is there, architect is there, then green building consultant is there, then landscape architect is there and contractor is there. So they are the stakeholders in taking up all these aspects of site planning. So you might not think like, okay, these and all are under the control of certain specific people only. No, it is not. So it includes owner, the architect, green building consultant and the contractor. Ultimately seeing everybody is involved, right? So you might be any one of them, might be owner or architect or green building consultant. So you can really play your own role there, right? So let's jump into again the aspects of site planning. So first comes the site analysis. So that's what we were talking about as ecological survey, but more than that ecological survey, there are certain other technical aspects under site analysis. So what are they? It's all about geographical study and climate analysis. So geographical study, it's nothing but understanding the existing topography, soil, underground water level, vegetation, etc. So that we can simply say it as site ecological survey. That is geographical study in other words. So apart from that geographical study, we have climate analysis to be done, because based on the climate, the orientation, shape and size of the building has to be finalized, right? So under the climate analysis, we have two different options: daylight analysis and wind analysis. So daylight analysis, it's like finding availability of sun for a given orientation in a particular location for the entire year. This ultimately helps in reducing solar heat gain, which ultimately helps you to reduce usage of external HVAC installments and ultimately reducing GHG emissions, right? So under wind analysis, so windrows diagrams can be used for understanding wind condition, wind direction and wind speed for a given site location. So how this wind analysis might be helpful for you? So it may be helpful for you in going for a passive architectural options where your building themselves can utilize the existing flow of air and quantum of it entering into the building, and so that you can ultimately reduce the dependence on additionally or installed mechanical ventilated systems, right? So how to minimize the site disturbances? So how and all this happens, first you should understand. So it's like a flow of chain of activities. So once you go and look for the development of new built environment, it's obviously getting disturbing with the existing topography. So that disturbances ultimately leads to loss of native species. So there are certain strategies and benefits. So why you should minimize the site disturbances? So first, strategies for preserving the existing topography. So designing landscapes with multicultural plant species and avoiding monoculture. So obviously it's like you should be giving significant time and effort to understand the native plants, so which are highly comfortable and accommodatable for the given location, and you should get seasonal wise adoption of different types of plants for your landscape, avoiding monoculture. So right, preferring native and adaptive vegetation. So native and adaptive vegetation further explains like, so every location has their own tendency of supporting certain plants and opposing certain plants. So those supporting tendency is called native plants. So they will ultimately require lesser amount of like irrigation over that invaded or foreign kind of plants for a given location, right? So in case of unavoidable disturbances, at least try to design the landscapes over the built elements. So this is very important, because ultimately we can't or all the construction projects can't design as an integrated one with respect to the existing ecosystem. So we might need to remove certain existing ecological features such as vegetations or water bodies, but at least once you build, try to implement or try to integrate the designs with respect to the landscapes over the built elements like roofing and walling or all those kind of things, right? So parking roof, vertical gardens, grass pavers are these kind of examples. So what are the benefits ultimately for by doing it? It preserves site biodiversity, obviously, enhances site local microclimate, very important, we will be talking about it. That improves on-site air quality, lessens construction cost by preserving existing contours. So existing contours in the sense, for a given site location, if you are if you are going to take up some 10,000 or thousands of meter square of built up area, means you may need to cover up a vast amount of land. So from one edge of the land to the other edge of the land property, the undulations, the ups and downs, that is nothing but the contour, would vary rapidly here and there. So normally what people do, they would first level it, right? So you just use the bulldozers or whatever the equipment you have, and you remove the earth from the bundled up the area and fill it up in the low lying area and just level it up. Then people would start go for the construction. So under the green building design criteria or these kind of strategies, what is being advised is try to go with the natural contour, because that will help you to retain the soil undisturbed to the possible extent, so that once you construct your building, completing it, afterwards you can use up those kind of undisturbed soil areas for growing the native plants, right? So that's what ultimately is being meant here, like lessens construction cost by preserving the existing contours, right? So next aspect of the site planning comes erosion and sedimentation control. So soil erosion is nothing but loss of soil from land surface due to gravity, wind or water flow. So once it happens, what it would lead to? Nutrient loss, exposes deeper soil which cannot hold water, aquatic habitat disruption, increased aquatic plants such as algae. So these are the issues. So how it can be controlled? So soil erosion control can have two different aspects: erosion control through soil stabilization and sedimentation control. So soil stabilization in the sense planting trees and vegetations, because those roots would help in capturing and holding the soil mass underneath. Then permanent and temporary seedings, right? So seedings in the sense not for some big trees or kind of things, but still, for like grass kind of things, so that it would grow up, minimum height and with minimal requirement of continuous irrigation, so that it would stay there and just to hold up this topsoil without getting eroded over the time, right? Under sedimentation control, we have different options like earth dikes, silt fencing, sediment basin and sediment trap. So these soil related protection measure has to be followed not only after the construction but during the construction as well. So if you see different visuals for under pre-construction measures, so these kind of strategies can be preferred: top soil stacking, site barricading, preserving existing vegetation and wheel washing. So wheel washing is nothing but like, so construction site is typically can be seen with a lot of vehicle movements coming into the site and going out of it for the purpose of carrying the labors, the materials or whatever the things, right? So whenever they come into the site and going out, during their wheel movement, a lot of topsoils are becoming swirled and being taken away, all the places wherever the vehicle goes. So that has to be avoided, because that is what being mentioned as the topsoil, and obviously it connects with the site based construction site air pollution issues as well. So wheel washing is ultimate a good measurement. Then preserving existing vegetation, not disturbing them, so that protecting them with some side layers of temporary fencing or kind of that. Then site barricading, so that whatever the topsoil is getting swirled into the air, but they are not leaving far away from the side boundary, protecting them or restricting them with the help of some barricading setups, right? Then topsoil stacking, nothing but, so it is being advised in case of a large projects especially. So the topsoil is nothing but the matter of 2 centimeter to 4 centimeter, people say, right? So those are the fertile in nature, and those have the capacity to hold up the water and hold up the nutrients and all those things. So those topsoils can be scrapped and can be stored safely at a particular corner of the site, so that once the major construction is done, then you can refill them onto the place again, right? During the construction, so these are the things can be done. Sedimentation basin, so it's a temporary basin at the lowest point in site, so that the rainwater or whatever the water spill, it's getting collect and stored sediment in that basin and make it settled, right? So it is avoiding the loss of the topsoil, right? So again, the same thing can be dried out and can be taken out and put it back onto the various parts of the site post construction. So contour trenching, so earth embankment or ridge channel arrangement to reduce the runoff velocity. So holds moisture, helps in minimizing sedimentation loading, right? Especially in case where the contour is vastly different across the site, right? Then finally we have earth dikes and silt fences, like temporary berm of compacted soil to channel the water to the desired location. So diverts the sediment laden water to appropriate traps, so that once the construction is done, again we can dry it and take back and pour it again in their original locations. Post construction measures, we have stormwater management like rainwater harvesting and runoff harvesting, maintenance systems, then a proper vegetation, right? So these are the things which comes under soil erosion and sedimentation control. Then we have the local microclimate issue, that is nothing but urban heat island. So in that visual you can understand, the left side end we have a rural, and in the right side end again we have a rural, and in the mid we have the core city. And the temperature graph shows low peak with respect to the rural ends, but in the maximum peak with respect to the central city areas. So ultimately urban heat island refers to the increased temperature up to at least 5 degrees Celsius in urban areas compared to the surrounding rural areas. So that temperature difference is being mentioned as urban heat island. So it is due to human activities, obviously. So we run machines, vehicles continuously emit heat energy. Then materials like concrete and reduced vegetations completely reflecting more sun into the atmosphere back than absorbing it, so that some like a zoning is happening around that city premises, so that into that zoning we feel more temperature, right? So that is called as urban heat island. This leads to higher energy consumption, because when you feel more sun, when you feel more hot, you need more refreshments in terms of using air conditioners or fans or whatsoever electrical equipments, right? So that ultimately worsen the air quality and public health risk in the cities, right? So what are the measures we can take? So we have options: designing open areas with more vegetation. So try to avoid the built-up area, that is what they are telling, right? Then paved areas and roads to have shade from tree cover. So try to grow trees along the shade, roads and paved passages. Then using open grid pavers or grass pavers. We will see what is that. Preferring hardscape materials with solar reflectant index of at least 29. So not higher than 64, which means they are giving a range for that SRI value. So shading parking spaces. So don't let the parking spaces without natural or artificial shading. So for the given roof type and respective slope value, they are suggesting some minimum and maximum SRI values. So if it's a low slope roof, 2:12, less than or equal to, they are suggesting the minimum SRI value as 78. And if it is steep sloped roof, which means the gradient more than 2:12, then you have to use minimum 29 and a maximum of 64. So why it is? So what is the difference between low sloped roof and steep sloped? So in case of steep sloped roof, if you are using more SRI value material, they would reflect much sunlight onto the neighborhood buildings, right? That is the problem. So that has to be avoided. There is a very significant and interesting case study in the internet you can find because of such glass building which was constructed in a particular foreign country, where the surrounded buildings felt more heat and even got melted because of the reflected sunlight from the particular glass building, right? So that kind of issue is the underlying reason for choosing slope based SRI values, right? Then we have the measures. These are the visuals for grass pavers and grid pavers. So grass pavers is nothing but, instead of making it completely like paver blocks, using it along with that grass things, grass layer, so that in the simulation you can understand the difference between complete red and red blocks integrated with green lines, right? So that's how the impact of different between plain pavers and grass pavers, right? So it helps in reducing the intensity of heat immigrating into the building through the roof surfaces. This is the paint which has some SRI values, and China mosaic tiles. So ceramic tiles in terms of the bright colors are preferred as a green building strategy for reflecting extensive sunlight from your rooftop, so that lesser ingress is happening, and that would ultimately help you to avoid using excessive HVAC installations. The next aspect is outdoor light pollution reduction. So the visual clearly tells you, in terms of our landscape lighting fascination, we may lose the connection between ourselves and the eternal sky during the night time, right? So the acceptable and unacceptable scenarios are being shown very clearly here. The first type of light, what you can able to see it here, is completely open 360 degrees, and it completely merges out that visible night sky from your point of view. So the next level of choice is putting a small lid over it, but still it is a very bad choice. And again, limiting the light per area and expanding the lid cover, but still it is a bad thing. So ultimately the better choice need this kind of complete surrounding your light, so that only the pathway would get lit up, not the eternal skies. So finally the best thing is fully shielded and timer based lights, because we may roam around during the night from 6 p.m. to 10 p.m. or maximum 11 p.m. That's all. But afterwards, the movement will be, outside movement will be reduced, and indoor movement would be more, right? Which means we may stay back, studying, doing works, or household chores, all those things. So at those times, when we just have a glimpse out of our window, we should be able to see the night sky. That's where we can connect ourselves with the universe, right? So those kind of motion based or timer based lights are highly better choices. So outdoor light pollution is the excessive or misdirected artificial lighting into the outdoor spaces, causing sky glow, glare, and disruption to the natural darkness. What is the point of view? It affects the ecosystem's human health and obscures the visibility of stars in the night sky. So you may wonder, is that very important? Yeah, it is very, very important. So under the same IGBC AP preparation course, finally we will have some occupant well-being as one of the module, where we will seriously talk about the connection between ourselves and the nature, how much it is important, so that to design a building to facilitate the continuous connection between the occupants and the external environment, that is the nature elements, right? So there are some ECBC baseline requirements are there with respect to the that how much the light power density should be there based on the location where it is fixed. So if it is a building entrance, 10 watt per square meter, and if it is a stairways, again 10 watts. If it is the outdoor landscaping, it is 0.5 watts per meter square. You can understand, once the location comes out of the building, the requirement is getting reduced, right? and 3 different rating ECBC, and accordingly the requirement will be more stringent, so that only you can understand from left to right the values are decreasing, right? So power limit ECBC building is the lowest rating, I think. So for that is the value. And if you want to achieve more rating with respect to ECBC, then you have to adhere to the more stringent values. That is the meaning here, right? So then we have universal design. So under site planning and very important thing, planning, universal design. So universal design indicates creating spaces that are accessible, usable, and inclusive for people of all abilities, ages, and genders. Which means abilities, ages, and genders, ensuring equal access without the need for adaptation or specialized design. So if you have a public building especially, or massive residential apartment kind of building setup, if you make, you should consider these kind of things. So if you are designing your own private home, in a big bungalow, that's up to you, so how you want it to be. But especially when you design public spaces, public infrastructure, especially the bus stations, metro stations, airport, right, government offices, government clinics and hospitals. So those kind of things, especially the malls, cinema theaters, right, obviously, right? So entertainment and all those refreshment areas. So those kind of infrastructures has to be taught so seriously in the early stage, so that the concepts of universal design should be adopted. So what are those elements of universal design? It's all about preferred car parking, toilet for differently abled people, ramps with handrails, very important, because somewhere people simply claim, see, we have both stairs and ramps and we are supporting the differently abled people as well. What about the handrails, man? So how they will climb onto the ramp? So they are not having some motorized wheelchairs always, right? So ramps with handrails matters. So what you see here in the slide as a visual, it's a huge stairs is there, but it's integratedly intertwining with some ramps, so that people of differently abled nature can easily just rovering onto it without much help of others, right? Then non-slippery ramps, very important, because non-slippery ramps are meant for old age people accommodation, right? So then visual warning signs, very very significant and important, because it is talking about the level of literacy one may have or may not have. So you just try to include everyone. You should not presume that the people who comes to this building would be a graduate in engineering or medicine, right? So the clear and clean, simple visual signs are one of the important universal design strategy, right? Then seating near lift lobbies, because lifts sometimes would be very important in case of very tall buildings with 20 plus 30 plus floors and all. So using the lift is ultimately need to be accommodated with lobbies near the lift, so that people don't need to stand, especially the kids, women and older people, right? Then walkways with adequate width, very significant. Narrow down walkways are not recommended, especially in case of public buildings or mass gathering buildings. Then lifts with braille system and audio assistance, so that blind and those kind of differently abled people can still use them effectively. So these are the simple examples. Reserved car parking spaces for the differently abled people, because they don't want to trouble themselves with the common parking area, right? Easy access to the main entrance, the ramp is there, and in the third image you can see ramp is there, but also with the handrails, right? So this serves two different purposes: supports the differently abled people and also supports old age people, right? Then in the last picture you can able to see the lift elevator systems are added with braille and audio assistance, right? Then in the first picture you see the seatings provisions near the lift, then toilets fitted with handrails. So these and all are meant for old age people, very significant, very nuantic. Then the adequate visual signs, because the restrooms are the ultimate locations where different sort of people would use in case of a public building, right? So which one I should go, so that has to be clearly mentioned. So it should include the transgender as well. So in the third gender image is actually meant for the transgender, that is actually also including that differently abled people also can use that as well. So that there might be some one particular room, the washroom or toilet might be designed for the differently abled people, right? So in the last picture you can see walkways with adequate width, so enough room to walk freely, right? So the final aspect of site planning is provision of facilities for the construction workforce, very important. So for enabling safer and healthier working conditions, so these kind of minimal provisions should be there. So facilities for the construction workers can be referred to the guidelines of the Building and Other Construction Workers Act 1996 and Rules 1998. So that international code provides the basic requirements for the construction workforce. So it includes providing them adequate housing, sanitary facilities in the construction site for both men and women, and first aid and emergency medical facilities to cope up with any unexpected accidents, and enough illumination at site, because they should not work in dark rooms, right, without knowing what is there, where we are standing or where we are hanging, right? So these are the ultimate things in case of site selection and planning. So just to revise, the entire site planning consists of site analysis, minimizing site disturbances strategies, erosion and sedimentation control issues and mitigation strategies, then that local microclimate, nothing but urban heat island and mitigation, then outdoor light pollution reduction strategies, finally universal design and facilities for construction workforce. So in the next video we will be moving on to the module 3, where we will be completely talking about sustainable landscape. Thank you.